Alright, so let's fill in a little bit more information below as we move forward. A couple questions to get you thinking a little bit about what these sine and cosine functions are, what these graphs are. The first is, when do the maximum values of y equals sine x occur? Alright, so when do maximum values occur? So if I look back up here, my maximum value, which is 1, occurs at 90 degrees. At the same time, if you think about it, this is only one period, so this is one time around my circle. But what if I go multiple times around my circle, which means I'm not just going one full time around my circle, but I'm going multiple times around my circle. So if I wanted to continue this pattern, so it's not just a period of 360, I want to continue this pattern along, I would have another maximum at 450 degrees. Well, how did I get that number? What's the difference between 450 and 90? That would be 360 degrees, right? They're coterminal. So if I keep adding 360 to a maximum value, I know I'm going to have another maximum value at 450 degrees. So this would look like a graph, for example, that kept going on and on in both directions. In this case, it's going on in the positive or counterclockwise direction on my unit circle. And I can just keep adding 360 degrees to those values, to my original maximum, and that's where all my other maximums would occur if I continued that pattern on. I also could subtract 360 and get negative degree measures that would also be maximums, and that would be in the negative direction. So positively and negatively. I know this is a really bad sketch, but you kind of get the idea. So when do minimum values of sine occur? Well, I know my minimum value of sine occurs at 270 degrees. But again, if I continue going around my unit circle and I keep finding coterminal values of 270, I know if I do another period on top of that, another full circle around, I would get 630 degrees. I just added 360 on. I would get another minimum at 990 degrees. That's adding another 360 on. And these just keep going positively and negatively as long as you want to keep drawing out those graphs. Another, if we go on to cosine, our maximum occurs, we have two of them, at 0 degrees and 360 degrees. And this makes sense because these are already coterminal. So coterminal means you keep adding 360 to your original to get your new degree measure. These two are already coterminal, that's why there's a maximum at both of them. So I could keep adding 360 on and continue to grow those maximum values just like I did above. Same idea, I have a minimum value at cosine at 180 degrees, but I could continue adding or subtracting 360 and I would also get maxes and minimums of our cosine function if we continue on the same type of graph. Alright, so let's move on to some more information I want to fill in before we get into graphing these sine and cosine functions. A couple more characteristics to think about and fill in. The first is to graph, and this is our general sine function and our general cosine function. The idea is that A and B are both going to be positive. They're both going to be greater than 0. We're going to use that just for this case. So when A is greater than 0 and B is greater than 0, we're going to use the following characteristics. And the first is, we can find the period of our function since one full circle around our parent functions for both cosine and sine are 360 degrees, which is one full circle around our unit circle, divided by whatever our b value is going to give us the period of that particular graph, that particular function. We'll talk about that in just a couple minutes. But the idea is that since one full period is one full circle around our unit circle, and since our unit circle is 360 degrees, right, one full circle around is 360 degrees, the idea is that we can take that value, the fact that one period is 360 degrees, divide it by our b value, and we can find the period of that sine and cosine function.